Hello.
No SQL
No
or
SQL.
SQL?
There will be no SQL mentioned today.
No
No
SQL.
SQL.
No, we will never say SQL or SQL today in that show. We
Hey,
just
Adrian,
say
how are you doing?
structured or non-structured, right? Or document based, actually.
I'm
Document
glad. I'm
based.
glad. I just got like 10 notifications from like a Agile versus Scrum flame thread, and I just barely disentangled myself from that. So, uh, the,
Shout out to everyone. We're looking for hot joints today.
yes. So today is about Adrian asked a question regarding NoSQL, what I think about NoSQL, and we went into a debate on Monday, on Tuesday, and
Raul wants to join.
Rule wants to join.
He
Yeah.
said, I interpret this now as never as I want to join.
And
Okay.
particularly the the topic of NoSQL came up, especially in the context of building React apps, building Next.js apps, because we've been using NoSQL databases all the time, but we never really analyzed it. There's so many. There's so freaking many databases out there, and for whatever reason, we only use two or three in small medium businesses. There's one SQL RDBMS. There's a cache equivalent, which is usually Redis, and then if you need it, there might be a document store in there, or an object store of some kind, or
Object
a
store.
hybrid.
Object store is very common these days as
Yeah.
a let's say, substitute for volumes, which is great,
Mm-hmm.
to be honest.
Yeah.
Because volumes are actually great in if you just have one server in one place and you want to
Mm-hmm.
have, let's say, a high performance regarding writing files, reading files. But
Mm-hmm.
in reality, especially in a cloud native environment, which is most of the time the case, then you actually run into other problems, and they are severe. So I think S3 is actually a good example for database, but it's not a topic for today.
I mean, we can mention it, right? Because those are more the SaaS or more the PaaS oriented. No, it is almost like a SaaS, right? So S3 is like Google Drive, essentially. I love a recent um, interview on, what is it? Back in Banter FM. Alex Debris. If you don't know Alex Debris, he's the guy that wrote the DynamoDB book. And I love the distinction he made. So he said DynamoDB is not really a database; it's more like a service. It's like Google Drive on steroids, right?
Yeah.
It's You got a key and you got a lot of data with that key. It's hyper scalable, but if you got the key wrong, and this is very similar to a lot of similar NoSQL databases that are key oriented. If you get the key wrong, then the only solution often is to rewrite the entire data structure, the entire data stream by rekeying everything. And rekeying is a term that you often hear in purely NoSQL or like fully serverless setups. Our background in small medium businesses, I think everybody starts off their app with some form of Postgres or MySQL. I think that's just, I don't know if that's things we us Europeans do, or whether that's our background, or whether that's has something to do with the cadence and the scale of the system. But generally, you would start off with a SQL database, um, which is
I could
weird,
never convince my colleagues to use something other than than SQL.
right? Right? Because that's um, so the notion of so I wrote an article about this, and I think it's worth just putting the article on screen real quick.
Yep. And the link, please, as well.
Yeah, I've already linked the link. Here's on the official channels, so YouTube and the other one. Just
YouTube.
let me the YouTube one. The YouTube one. Right, where's that? Present. Share screen. That one. No audio. There we go. Right. So I shared this particularly because I wanted to highlight what's really going on, right? So the disconnect happens. Okay, font size, right? The disconnect happens somewhere along the lines of I want to write simple queries, but at the end of the day, what I want is the thing on the bottom, not what the query I wrote. So there's always this intangible in-between step that has to be filled by PHP or by Node.js or by Ruby or by Python. And we keep playing this weird data game where some part of the data is on the database and some part of the data, for some reason, is on compute, is on the app on the backend side, right?
In the services.
Yeah, and then you get this typical advice of how do I make my SQL better? Well, they tell you try not to hit the database as often. This is typical advice. Cache your calls so you don't have to hit the database. Try to create such queries that a covering index can return everything. Or don't select columns you don't need. Only select the width of the row that you only need and as little rows as possible. But then if you use caches, where does the cache go? In a NoSQL database, right? So if I'm telling you to use a SQL database and you're experiencing high volume, usually the default strategy by everybody, by 99% of the people that I work with, their solution is, oh, our SQL database is so good, it's super active. Let's make it less active by using a NoSQL database in between us and the database, right? Have you ever noticed that this is a trend? Nobody goes, no caching, no nothing. I just want to have a really speedy database that I can hit all the time. Now, why is that? How come that never happens? And there's a simple reason for that. Most SQL databases actually suck at user-facing APIs. They don't have a web API, right? So
no, you mean NoSQL.
Sorry, SQL databases. So Postgres, MySQL, Oracle, MariaDB, Percona, they have baggage. And one of the baggages is that they very rarely, how many of you, one in chat, if you've ever seen the too many connections error on MySQL? One in chat, right? I'm raising two hands, right? So the SQL databases, the SQL, the SQL relational database management systems, they were created always with this assumption that there will be an application in between, gatekeeping connection pressure. And that is the first line of defense that fails. So we constantly seek NoSQL solutions to bypass this issue. Because if I have a lot of volume, if I have a lot of traffic, well, of course I'll hit the database. Well, but if the database can't handle connections, a lot of concurrent connections, then
yeah,
that's still only one, I mean, I don't know. Is it? I don't think. Is that a valid operation? I don't think you can. Okay. No math jokes. No math jokes. I promise. Right. So that's the first thing that it sucks at. But then you might say, well, can't I cache the results of the SQL query in the SQL database? Right? Because somebody thought about that. And the answer is, well, no, because that cache is ephemeral. And the SQL database is not very good at keeping temporary data. Plus, it's not very good at keeping temporary data that isn't relational, where it would have to be a document. And at the same time, is also not very good at releasing disk space after you deleted that temporary data manually. Right? So if you've ever maintained a MyESAM or InnoDB cluster of master-to-master replicated MySQL servers, you'll know how annoying it is to reclaim disk space if you happen to have an application workload where you delete a lot of records. Maybe you have manually materialized views in your database, and
I remember in SQL Server that was a big problem when that happened. You actually needed to have loads and loads of RAM and disk space in order to mitigate that and ease out that problem over
fully
time.
Duplicate it and copy it over so that you can repartition so that you can rebalance the, what is it called? Partition file, I think.
Yeah, I remember. So it got better with so it, at least from my let's say distant view perspective, since I'm not a typical backend engineer here, so for the audience. But
You know
but
enough about backend to be called a full stack engineer. So
yeah, that's true. But I'm not a specialized backend person. So
fair,
the
fair.
last time I wrote a SQL statement or something similar is quite a while ago, and yeah. So what I wanted to say is, let's say what we use lately in the Postgres in the area, we have a lot less problems with that, and we need a lot less compute power than we had with SQL Server. SQL Server seemed to be a little bit faster in general, but you had loads and loads and loads of hardware. Throwing after it in order to run properly. So there was no small SQL server. It was always like SQL Server was always so large, and I think this is one of those inexpensive. This is another point,
and one of it,
yeah,
right?
one
So
of
it is
it, yeah,
one of it that is vertically scaled, not horizontally.
No, I am not. I am not developing in the backend area, but so I'm very close with the teams discussing everything.
Are you
But
replying to Raul's
sorry,
comment?
sorry,
Yeah, yeah,
so that was a little bit, yeah.
yeah.
So
Raul
Adrian
asked
Su,
if you're-
he's asking me, Raul, if I'm the ORM person. So we use ORMs. In particular, Prisma is in usage, and we are actually happy with that. But I am not the person who can explain exactly. I know there's a person in the audience who could, but this is another topic.
Okay.
And yeah, so actually, I'm not like I can't speak like a waterfall today about that, but in general, it feels a little bit like so let me click quickly because you said ORM. ORM is actually a topic for today as well because ORMs are
It is.
they are existing in both areas, and it is important to understand them. And ORMs is a little bit like when I come now again to my Tailwind anecdote. It is about the engineering aspect. So we want to focus on specific engineering aspects and not too much to the very granular things, even though it is possible to do that in Prisma, for example. Then I know that from the past that we could do manual querying. It is possible, but we actually don't need it, and we don't have problems with that. And it helps us to streamline the process in a way where we don't need to go too deep into the SQL area. I know this is controversial, but we never regretted this decision. Yeah.
So
yeah.
I mean, we can go in a little bit deeper into it. Like, so what's your opinion about ORMs? Like, why do they exist? Why do we have ORMs?
Yeah, good question. I don't know exactly why they were invented in the first place, but for us, I can say that ORMs are helping us to reduce complexity and streamline the process. So it is about that you can describe what you want to do basically at code level, and instead of doing that at the database level. This is just a let's say a conscious decision we have made to streamline the process, as I said, in combination with GraphQL mostly. And actually, this works quite well, to be honest. We don't see any specific performance issues because of that matter that we use it. We have actually a good management regarding migrations. This is actually a great thing, and it feels pretty good to work with that from the perspective now of a person who is more high level or on the front end side, which is me.
Of course, because it solves this problem, right? It solves this problem that's on the screen, right? It helps you go from that to this. With GraphQL specifically, because that's what GraphQL actually was set out to solve as a protocol.
Yeah,
is to say, okay, well, you keep using your ORMs. I'm going to put something on top of it, so I don't even have to think about that problem anymore. So from my perspective, ORMs are solving a very particular problem in the backend.
That's a good point. That's a good point.
In a way, an ORM is documentation for the database. I mean, that is a good point. I like that take. It's documentation for the database. Yeah. Because you often do migrations with your ORM, or at least you backport it to your classes or whatever you're using, right, via reflection. So that is a good. I like that take. Thank you, Jonathan. So from my perspective, ORMs solve a very particular problem, namely that the language that databases use to ask you for what you want to query is actually a declarative language. And SQL is the most widely used declarative programming language in existence on the internet, period.
Mm-hmm.
So if you're telling me you don't know a declarative language, you're lying. You know at least SQL. So that's what it looks like. There's no loops, there's no variables.
15 years ago, it was
There's no-
impossible to develop any form of software without knowing SQL.
Yes.
As a common, typical XAMPP stack
So-
developer, right?
So specifically what SQL is solving, what ORMs are solving, is that in order to dock to the database, you need to write in a programming language that is not the same as the programming language you're using in the database. There is no backend server that runs on SQL, if I describe it that way, right? Your web service layer, your REST API, is never written in SQL. It's always in a different programming language, like C#, like Java, Script, Java, Ruby, Python, C#, Go, Rust, Zing, I don't know, TypeScript. Right, so the point is, if you write another language in the language you're writing in, you get this weird JSX problem, that you have a stringly typed problem where you end up writing freaking HTML in strings in JavaScript or CSS in JavaScript, and exactly the same solution as Tailwind provides to the JavaScript developer, ORMs provide to backend engineers who write SQL, right? In that it abstracts away the stringly typed area where at some point I have to do like weird, really clumsy string concatenation, and in some cases complex string transformations, which if done incorrectly might actually lead to security issues, performance issues, data leaks, etc., etc., etc. And that's why we have ORMs. It's just abstracting away the stringly typed problem of not having to lose my freaking mind concatenating together. So I need to add the column if I have the where condition, but on my pagination call, when I'm counting, I need to take them away, but the where condition stays the same. And when I'm joining, it has to be in the right.
Exactly.
So everybody's done that. Everybody has started writing their own ORM at some point where they said, I'm not going to use one. I'm just going to
helper functions. If you have a lot of helper functions, you have an ORM. But yes, ORM is what modern ORMs do well is fulfilling the idea of the quality of substitutability, which is the substitutability of the actual data DBMS. So, for example, if you want to migrate from Postgres to Maria or vice versa, which is more likely, then you can do that and you can just keep everything, which is kind of cool, right? So having that in the repository, in your repertoire of tools is actually a good thing. So I would keep that in mind as well. So this is what I meant by ORM. For me, is a form of engineering. Of course, there are people saying, yeah, but if you really need to have control over your database and extremely performant things, then I understand.
That is always an architecture problem, not an ORM problem.
Yeah. So what in my opinion is, let's say, this is again this typical thing. Most of the applications don't need that. We are still talking about let's say, just a small amount of data you actually query and aggregate and bring it to the client. It's not too much, right? It's not like you don't need it to have it below a millisecond or something like that. It is. There are some of those things, but you have, let's say, other things like caching mechanisms, which you need anyway, especially when you go into scaling. Then you can't do everything via the database. This is the other topic, because databases are harder to scale than, for example, Kubernetes pods, for example, or services, or even functions, or Redis service, or something like that. This is something we need to take into consideration as well.
Yeah.
We have some comments. Should we go for them?
Let's go over the comments. So that's one of the Thomases. Thomas says, an ORM relieves you of the work of building complicated joins at SQL level. So again, I would highlight the stringly typed problem. You're still writing the queries, but you're writing the queries in your natural programming language, not in concatenated strings. That's really important. right? So you're solving the object-oriented typing problem. You don't have to use classes or objects, but you are using your programming language's native types to say, this is a row, this is a column, this is a result set I'm expecting, this is a where condition that sometimes I need, sometimes I don't, this is a predicate, right? So even if you're using an ORM or an ODM or a debal or a active record layer, we've gone through all generations, even GraphQL. GraphQL will have keys, artifacts, will have providers, right? So it's all the same, but it's solving the stringly typed problem. And GraphQL is in itself also a stringly typed problem. So if you need dynamic GraphQL queries, then you also need an ORM on top of GraphQL, and that also exists. But I forget what they're those are then like hipster level abstraction frameworks that nobody really needs, but they're just fun to have. But Thomas finished in saying, in my opinion, it is an abstraction for the underlying SQL statements and thinking in objects instead of data. Ty follows up. Thomas said it well. Hello, Ty. It's about thinking in object instead of data. Once you need to write a complex query, going to an ORM is hell, and you'll fall back to the power of SQL. So when we're talking about objects, so I don't like conflating the term object too much. So Postgres is an object database. MySQL isn't, right? So every row in Postgres is an object. In MySQL, it is not. So rows in Postgres have object IDs. You can invoke functions on them that you can't in MySQL, right? So even that, the word object may be very confusing depending on what you're used to. Also, objects to me in object-oriented programming languages are about behavior. So it's about the methods and the classes that describe the types of those methods, and particularly in TypeScript terms, the interface, the type definition, or the canonical form of the method definition. So I would say it's about thinking in DTOs instead of data. So it is more than just, so it's more like a struct, less so like an array of strings, right? So the property itself holds some value. It might be structured in some way, but usually it's not a tree, right? So the secondary purpose of ORMs is to handle the relationships between the tables, not so much the tables themselves, right? So if what you're doing is just querying everything from one table, then you don't need an ORM. You need an ORM once you have relationships between the tables. Once you have a certain order to, I need to create this thing because then I get its ID, so I can put this ID in that other things. And then if this one fails, I need to roll that back, right? That's the problem ORMs are solving, because it's a relational database. It's not an object database. It's not a database. It's not a row database. It's not a column database. It's a relational database. So the point is the relationships between the tables.
And I ask myself,
a lot of people miss that mark. But it's not Snowflake, right?
Where's the upper ceiling of complexity? Where's the upper ceiling of complexity in regards what Ty just said? So what is, maybe for the audience as well and for you, on some point, in my opinion, you should think about the architecture instead of doing too complex queries. This is what I see basically as a basic rule. There's always an upper ceiling of complexity.
Well, that's why we're talking about NoSQL today, right? Because Ty mentioned once you need to write a complex query. I'm just going to put his comment back on screen. Oh, sorry.
Me too.
Yeah, you too. Once you need to write a complex query, going to an ORM is hell, and you'll fall back to the power of SQL. Actually, once you need to write a complex query, you'll actually fall back to the power of NoSQL. Because whatever that complex query is, you'll either be caching it, or you'll be flattening down whatever that complex relationship was into a tree-like document, which is a much better fit for a NoSQL document, right? So whenever you have that ORM hell problem with SQL, most people then solve that problem with NoSQL databases. But that's not actually why NoSQL databases exist.
But let's quickly, Jonathan followed up. That is a valid point, but shouldn't be an argument against ORM, and I agree.
Definitely. That's just a misuse. Yeah, that's just a misuse.
And again, it's rare, and and that it's rare that you need
Mhm.
really complex queries. This is the same what I said.
Yeah.
A good ORM should give you the possibility still to
Yeah.
do
So
that.
for
And this is,
example,
yeah.
I'm an SQL freak. I love SQL. SQL is my strongest programming language. I can write
And
some
it was
really
my
nifty
reason to
shit.
go to front end.
I can write some really nifty shit in SQL. But I have never seen an ORM handle window functions gracefully. I have never seen an ORM handle complex aggregation functions gracefully. I have never seen an ORM not shit itself when I start talking to it about materialized views, right? So there are limits to what you can do. And usually ORMs only handle like the most primitive atomic pieces of what a relational database, an SQL database, is capable of, and then sort of gives up on the rest. I'm not a big fan of that. Awesome participation in chat today. Like
Especially
we got
they
some
start to
really cool.
discuss with each other. And this is
Yeah,
what
we
I
got some
actually
really
like.
cool discussions going on. I just want to honor the first comment. So the first comments today were from Thomas. And Thomas mentioned, was the main idea behind NoSQL to have a database that contained an expandable and untyped document? And no, actually, that's not the main idea of NoSQL databases. You're really close, though. The point was that, so one of the core ideas behind NoSQL databases was that the primary key was not a sequential surrogate key. That was one of the primary components of a database. Because what is unique about SQL databases, about SQL, is that everything is in a table, and the tables are ordered, and usually ordered by a synthetic surrogate key. And if you want to learn more about that, I can recommend 𝗪𝗵𝗲𝗲𝗪𝗲's talk. So surrogate key is the lowest quality. It's the auto increment column. It's the sequences, right? Because that is what prevents it from being clustered. Ever tried to do master replication on Postgres? Have you ever clustered a multi-node MySQL database with relationships between the tables? It's pain. It's near impossible because of the overuse of surrogate keys, which are meaningless, which are just 1, 2, 3, 4, 5, 6. I add, and when I tell people to go to event sourcing or to consider different modeling paradigms, they ask me, well, how do I create auto increment columns? Like, why do you need them? Right? If I buy an apple in the store, why do I need to define a auto increment key to my purchase? Okay, just right. Especially if it's the first apple that I'm buying. So the problem is SQL databases do not behave well when you need data locality, right? So SQL databases, because they have schemas, because they are structured relational databases, they have structural locality. They have locality in regards to their schema, to their tables, right? So everything in the users table will be close to all the other users. But that's not what we want when we write a query that's something like this, right? So when I say John Doe and here's his email and here's his address, what I really want to say is that on disk, I want John Doe's user record to be really close to his addresses. And SQL databases don't do that. It's really hard to do that with SQL databases. And that's why they are hard to partition. And that's
you
why
always
they are hard
have,
to cluster.
at least if we talk about connaissance, you have at least a distance of 1 at minimum. While in a document, you could have a distance of 0 because it's in the same document.
Yes.
This is, I think, if we go back to the idea of connaissance, it's actually a good point. It is one of those points why front-end developers who are doing mainly front-end always tend to think about, Mongo is actually a tempting idea. Because
they're coming from this. I have a flat single perspective viewport on the data, and I'll prefer it structured from my viewport. Rather than the relational aspect of if all unique data I want stored only once in an efficient manner. And efficient means that it is stored next to other things that are similar to it in structure, but similar to it in structure, not similar to it in semantics, right? Because I want Dennis's address being close to Dennis's user row. That is similar in semantics. Adrian's address being close to Dennis's address, that is similarity in structure, in schema. And SQL favors the latter, and NoSQL databases favor the former. And only databases that form data locality close to a key, close to a value, close to a domain property, those can be easily clustered, right? So NoSQL databases saw a rise because they were much easier to cluster. Ty and I worked together at a company that prided itself in 2009, 2010 for being one of the few companies that used MongoDB in production on the year that MongoDB made its first release. We had like a 5-node cluster running because it was the only way. MongoDB was one of the rare technologies back in the day. And this is 2009, not so long ago. MongoDB was one of the easiest ways to set up a multi-node write and read cluster, so that you could write and read. If it's read only, then setting up read replicas in an SQL database, no problem. If you're happy with the delay, no problem. But so that you can write to them as well, and that certain data have locality between them, so you can actually
it's a recipe for split brains. Yeah.
And you have on SQL, hell no, right? Because you get this marshalling problem of I have two databases, and I have this risk of any query can potentially hit both nodes, or one of them dominates and all queries hit one of them, and then a moment later, all the queries get duplicated to other node as well. And that's just pain. Then you add a third one, and it just keeps exponentially slowing down the SQL database. And that is a problem that Postgres and MySQL and later on Percona and MariaDB have not solved until 2018, 2019.
Am I still here?
Yes. Did something happen? Did your Wi-Fi drop? You're still here with us, Adrian.
Yeah.
Is everything okay?
You were away for me, but internet was still there. I don't know what happened.
So clustering, to answer Thomas's question, clustering is actually the first things that NoSQL databases did really well, because it was a problem that SQL databases notoriously didn't solve very well, right? So time series data, ephemeral data, right? So ephemeral data meaning save something and have a TTL of 1 hour. After 1 hour, I wanted the record to disappear. This is notoriously impossible to do in SQL databases, even if you have stored procedures or triggers.
You need jobs for that. Cron jobs.
You need jobs. You need cron jobs, and it immediately increases your compute complexity. Because then the compute cluster also needs to know, okay, well, how do I synchronize this? Does it happen all at once? If the cron job misses it, is it allowed to do it backwards? How far backwards? And you have this like subscription problem of, bitemporality of it should have been deleted, but it wasn't. So now that it's 1 hour later, should it have been deleted now, right? To make it appear as if it was in the past. So you have all these bitemporality issues because you cannot make these TTL deletions atomic in an SQL database, which is also something that they struggle with. And then there's the text search, which then later on MySQL and Postgres got extensions for. That's why Lucene and Solr were created, and later on it got bundled into the Elasticsearch, and now OpenSearch project. You have issues with time series data, where you only want the newest data, right? So if you have like IoT services, like a light bulb telling you if it's on or off, or if you have a temperature, probe, and it might actually sporadically give you a lot of signals in a short amount of time. And what you really want is the average across the last hour. It's very hard to create an SQL database for that wouldn't inefficiently use disk, right? So that's, again, something NoSQL databases are very good at. And again, it's almost impossible to solve this problem in SQL without also having a whole compute node or serverless functions or cron jobs or some kind of persistent stateful out of process background jobs or equivalent, which is why these solutions came to be.
Let's go through the
Yeah.
stack of. We have a
That was
Stack
Thomas.
Overflow.
We have a Stack Overflow.
It is
Thomas said, I understand caching and the meaning behind it, but when it comes to databases, it's not about caching results, is it? So from a DB perspective, caching isn't the main issue of a DB, right? I mean, it is, but it's an issue of a different DB. So, you know,
I mean, databases are caching, but it's like it is not the grade of caching we need in
well,
applications.
caching implies that there is a gradient, right? So that there is a layer in front of that other database, and this database has, let's say, has different trade-offs. That one's more durable, this one's faster. That one's more reliable, this one's already structured, right? So it's converting CPU cycles, it's trading CPU cycles for disk space and potentially stale data, right? So think of it as video compression. I can either send you iframe for iframe and nothing else, and it'll kill your bandwidth, but your CPU can handle any movie. Or I send it to you compressed, and then bandwidth is happier, but your CPU now does more work. Right?
Same as we do with StreamYard, actually.
Yeah,
it's the vice versa thing. So we don't need to do anything regarding GPU on our PCs. It's just recording the plain signal, and everything else is done on the service. It's basically vice versa.
So when I say caching, what I mean particularly is that there's a weakness that we're trying to address. With databases, it's usually the connection pools. Because databases are SQL databases. They are organized in such a way that to maintain transactional safety, because most relational databases are transactional.
Yeah.
At least the MySQL, Postgres, yada yada yada.
But MySQL wasn't. But
MyISAM wasn't. MyISAM in MySQL wasn't.
But the free version, I think the professional version was always strange. I remember, let's say 15 years ago.
Yeah, the community edition with a defaulted to MyISAM wasn't, because the transactions. It also auto committed. You couldn't have complex joins between MyISAM tables and InnoDB tables. And if you were to open a transaction and cross that boundary, there were rules on when it would auto commit. But I think most people don't even know that existed. So I don't want to waffle on too much about that. Anyway, I'm very, very, very passionate about SQL. Yes. So when you're talking about databases, what we mean is that you're probably transforming the data in some way. So we're saying, well, don't redo the join because that's compute heavy on the database. Store it in a different database instead that's optimized for retrieval per key, or retrieval and then has the functionality of being able to destroy the cache once it becomes stale. For example, Redis, right? You can put it in Redis as a JSON, and you can tell it, hey, delete yourself in 1 hour.
Yeah.
And then you optimize that, right? Because Redis is also serving from memory, not from disk, right? So you also have a different hardware component to it. That's one area. But again, the connection pools are solved as well. Vitess is solving the connection pool, right? So Google
exactly?
Vitess is the driver. It's like a database proxy. It's a bit more complex than that. It's like a clustering facade in front of MySQL that Google developed and then open sourced. And now I think it's part of the Linux Foundation. I think it got adopted by the open source community fully. And Vitess is one of the first sort of approaches to getting this sort of cloud native hyperscaling for MySQL, where I can connect to Vitess, to the MySQL proxy, and then it will tell me like, okay, you get these 10 rows from there and these 5 rows from there, and then the query planner knows how to communicate with many MySQL databases, and then put them together and then give me a MySQL results. Right, so similar to how GraphQL operates with resolvers, but the output format is maintained to be MySQL and MySQL driver compatible. It's that MySQL driver compatibility that's really the selling point. So you're basically talking to a cluster of databases, and you're sort of trying to figure out not having to deal with that from the user's perspective. Plus, it also allows absurdly higher connection limits, whereas MySQL and Postgres would basically kill themselves at like 200 unique connections, which means if you're opening like 1 or 2 connections per request for whatever reason, or if you might have a debug connection open, or if you have microservices and you're parallelizing it and it becomes, even if you're using a connection pool, maybe 6 connections open per request. And on the extreme side, if you're really going heavy, then 20 users can kill your database server if you're not careful.
Yeah, I know, we know that problem.
Yes, everybody. Again, one in chat. Too many connections is something everybody encountered, and as an engineer, you never think that you will have that problem, that you will have too many database connections to your database.
Yeah, especially you develop. You
don't expect to have that problem.
You develop on yourself with you as a person normally. Yeah. You don't do load tests all day long, and then now you go to staging or production, and suddenly those problems happen. And those are existing. But let's go to the next one, because otherwise we won't get to the actual topic.
Amazing comment, chat participation.
So Thomas says again, Thomas 2, to be honest, the syntax and SQL are not the problem, in quotes. It's more about the dynamics of documents at runtime. It's about the query speed, and it's about the type of protection, in quotes, and behavior, in quotes, atomic, in capitals. There are things that NoSQL does differently than RDBMs. What do you say about that?
I think that's an oversimplification. Most NoSQL databases are atomic. They're just not transactional. Not all of them have transactional guarantees. Because if they would, then you wouldn't be able to easily cluster them. But they're still atomic. Like, atomic is different to transactional, right? So we gotta, what most people want is ACID compliance and some level of guarantee. Even Kafka has this, or DynamoDB is a very good example. In DynamoDB, you can even set it. You can tell it, what do you want when you set up a database? You can tell it, well, do I want an immediate response at the risk of it being slightly stale? But I would want to know if it's stale or not. Or do I want a slower response at the guarantee that it was written to at least 2 regions, or to at least 2 nodes?
Is it still eventually consistent?
Yes. So you can.
So in the end, it's consistent.
It's not a fixed guarantee. You can have no tolerance for eventual consistency or full tolerance. Those are 2 options, and then you can also decide to be somewhere in the middle. You can also decide that under P99 I want to be here, but I also want the durability. But tell me if it's not, rather than blocking. Whereas MySQL will favor one and NoSQL will favor the other. So for example, in Redis, if you have like a split brain, or if one of your nodes crashed and it starts doing, Redis is also single-threaded, which is it chooses a whole bunch of other problems. But once there are issues, if it decides to block, you have to explicitly say, hey, this one command I don't want to be blocking, in case I'm in that rare case where it is blocking. And that usually catches you off guard, and then you have weird inconsistent behavior. Here, at least, you define it on the server level of saying, this is the guarantees that I give, and when I have trouble, I have been configured to talk to you like this. Right? So in MySQL, for example, there's often this issue of, at 10 open connections, everything's okay. But at 1,000 open connections on MySQL, every open connection is using so much memory that the capacity to handle a large query is much lower. Which means that there are some queries in your system that are extremely slow only when there are a lot of connections open. And if you're not monitoring that, then that might be very chaotic, or it might appear as chaotic or unexpected or exotic behavior, right? And MySQL isn't configured in a way where it would say, hey, you probably don't expect this to happen, so I will fail early. I will never allow you to run a slow query, which is also this point that I mentioned here, that SQL databases have strict no mixing of OLTP and OLAP use cases, right? So if it's an OLTP database and you put a data scientist with read access onto your hot write database node.
Can you explain those two abbreviations for a HTML artist?
So OLTP and OLAP, think about it as if you're in a grocery store, the cash register, the cashier, if it's an automated checkout terminal, that's the OLTP database. That's a database that you write actively to. That's a transactional side. The OLAP database is what the accountant uses at the end of the month to figure out how many purchases were made, right? So that's the analytical.
So it's the read-write separation, isn't it?
No, it's the locality versus global. It's the user-facing versus business-facing side, right? So on the user-facing, Dennis cares about Dennis's stuff. And on the business side, what the business cares about, give me everything that happened in March, which is something a user never does.
And why do you love ClickHouse? What is ClickHouse?
ClickHouse is a columnar database where that is simplified, and it has SQL syntax. So it makes it easy to maintain the relationships as if it were an OLTP database, but it is optimized for OLAP use cases.
Okay, and how does this relate to CQRS in this case?
CQRS.
Yeah, this is a little bit like maybe it's the wrong topic, but not from a database standpoint, but from the idea of separating this. This is what I mean.
Well, OLTP and OLAP use cases do have different projections in mind, but I don't want to go too much into detail about CQRS right now because we still have a lot of comments. But it's a great question. It's a great question. Maybe we can reiterate on that.
We need to do a CQRS again. I think
I think we should. Tim mentions I use the progress the program. Is that meant to be Postgres ABL? Is that something I don't know? OpenEdge Advanced Business Language. Interesting. No, it is Progress ABL, which is record-oriented and supports embedding the query call with processing records one record at a time. I learned something new today because I didn't know about this. Interesting. I need to look at this. Thank you, Tim. I wasn't aware of this.
You were telling me you know everything. This is disappointing now.
No, I know a lot of good shit about SQL, but Progress ABL, I don't know. Maybe this, I learned something new. It seems like a really interesting declarative superset on top of SQL. Pretty cool. Time mentions, in a typical use case, most of the time you're doing CRUD. And ORM makes it easy to do that. Okay, so this is still the ORM debate. And ORM makes it easy to do that, plus having the relationships in code to easily get the user from the order, for example, is really useful. Yes, it is useful, but honestly, it is a little bit of a guardrail. But it's useful for the first generation of the code, where it's greenfield and everything is in fourth or fifth denormalized, in third or fourth or fifth normalized form in the database, where you have users in the users table and the orders in the orders table and the users orders in the users orders join table and blah 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 blah. But then once you start making migrations, and if you're serious about your business, your migrations are backward compatible. More and more of your code is writing to two tables at the same time because it is writing to the legacy side and to the modern side at the same time, especially if you're doing some kind of federation slowly or legacy modernization or strangling thick pattern. It's often the case that you're using transactions to write the three nodes at the same time to guarantee the three different levels, the three different versions of the code, rather than the consistency aspect. Plus, I often see then users getting yoinked out of the database and put into some kind of identity management system, and usually the transactional guarantees were never needed in the first.
How does it play together with the ORM now in your case, in your example? Is it good or bad to have an ORM in such a situation?
Well, what I'm saying is that if you have a CRUD example, CRUD being create, retrieve, update, delete, then CRUD doesn't mean that query is the retrieve, the read side, right? So retrieve CRUD is a REST acronym, which means get by ID 5, which means that the read side is always simple queries. if your query is a large join that has complex conditions and an aggregation function in there, and it's basically projecting data into a new form and aggregating data in new form, that's not CRUD anymore. That's my objection here, is that most people who say they are doing CRUD aren't doing CRUD. What they are doing is they are making projections. They're using their OLTP database. They're creating projections of the data, views, materialized views, aggregations, analytical histograms, charts, very popular use case, right? Charting software, you need to join all the dates, and you need to make sure the zeros are there, which is not stored in the disk, hopefully, right? They need to multiply them out and draw some secondary deviations and standard deviations, first, second, third magnitude. Those things are not in the database. That you compute. Those are projections. That is no longer CRUD. You're not retrieving something that's in the database. You're transforming it before you're sending it back. And an ORM is a very bad use case for that. The problem is that when I see people use ORMs for CRUD, they really cheat on how long they stay on that CRUD fantasy before they realize that their use cases are no longer simple. Yeah. And then if they neglect getting away from that, it's possible that they incur so much negligent code or tech debt that they actually can't get away from that anymore. Because if you were event sourcing and you mentioned CQRS earlier, the best solution to that is to not have a unified data model. Is to have a copy of the data for each unique use case that needs a slightly different rule set. Maybe I need sports games, for example. Sports games, you have a leaderboard, but then depending on who you are, whether you're in the audience or whether you're handling bets, sports bets, or whether you're handling TV stations, somebody might have a delay. So maybe they will need a delay on how old the data is in their database table, without them having to sort it out. Or they might need the data to be verified. So for the live audience, you send all the unverified data and then you'll undo it. And to the betting station, you only send the verified data, right? So it's very likely that you actually need to write to several projections in real time, then query from the right one, rather than computing it on the go, as it is with most quote unquote CRUD operations, right? So these are all data engineering problems that oftentimes engineers opt not to use the full potential of the database, just what the ORM supports. And I think that's my main objection with ORMs, is that the database is capable of 5,000 features. If the ORM only supports 10, if you only use 10, I think you're wasting the tool that's in front of you for no reason, for no benefit.
Yeah, but there we come back to the upper ceiling of complexity. You need to define what you actually need from a database. This is something I would consider, right?
Well, I think so,
because there's another aspect. So you need to be able to switch your application. So you should disconnect and decouple your actual application and infrastructure from the used databases. Which what I mean is, if you take a look, hey, what can I do with Postgres right now? And you actually just have a simple web app. It doesn't make sense to go into very specific functionalities of Postgres while you might not have always Postgres available, because many people should not host Postgres database in production themselves.
A lot of people don't configure the databases either, right? So
exactly. So
DBAs ran out of fashion. A lot of software engineers don't know how to configure a database anymore, and mostly they spin up a database. It's using default configs, and it's not optimized for the use case. And you can squeeze out so much from a database if you configure it well, right? If you configure the page sizes correctly, if you configure the connection limits correctly, if you configure the transaction boundaries, the default locks, where the locks are stored, how long the locks are stored, what the default timeouts on the locks are. And these are just small things. Like you can go and configure really large details that you say, I will never do this weird thing on this database. So I'm prepared to take this risk and make it a lot faster. But you said it's about the database. I would say it's not about the database. It's about the data that's in there, right? So the business is about the data that it owns.
Yeah, this is actually what I mean. So it is not about the features of the database. It is about what is inside, and that what is inside should be kept as simple as possible. So just because
I
I
agree
have
with that. Yeah, I agree with
just
that.
because there is maybe a functionality in a database, and a very specific one, that maybe helps me a little bit, and I don't need to do that on the compute side. I would rather say do it on the compute side instead of the database side. But then I still have agnosticism as a quality, and this
Well,
is on
this
the
is
long
where
term. It's more important for me actually.
this is where the overlap or where the contrast to NoSQL databases comes in. Because really what you want to figure out is, can a human operator modify state correctly in the database by hand? Or does it always have to go through the application? Right? So it is this romanticized idea of, is a database standalone? Or is the database inherently part of the microservice it belongs to? Right? So am I allowed to look in the database without talking to the server? Am I allowed to write into the database without talking to the PHP server, to the TypeScript server? Right? So that is fundamentally an architectural concern, a mindset concern. Because if you're doing, highly scaled, hyperscaled microservices, the answer to that should always be no. Developers even shouldn't have access to the database to connect to it, right? It should only be through the application, because then the application can do
Only
much
by
stronger
this
guarantees.
service, not the application. By this
Yeah, only by
service.
this service, only by the code that's in the compute of the
By
service,
the owning
or the
code,
serverless
actually, by the
functions.
gatekeeper in this
By the
case.
gate, or by tools that you create, which are also code, but not by connecting to the REPL, to the interactive console of the database management system, right? So that's where the philosophical aspect here comes in, because a lot of people build software in such a way that if I need a domain constraint, that I say I have an invariant here of a customer can only have 3 shipments in flight. Well, that's something very difficult to express as a SQL unique constraint or index, right? Do I want to have that structural integrity in the database? Because if yes, that's really hard to do, right? Because it's not ACID, it's not atomic, so there will be this hop with the database.
But in your example before, it's part of the service which owns the database
yes,
to decide that this is part of the logic.
But the service has a role in guaranteeing atomicity that is outside of the database. So if the database is clustered, now this concern becomes larger, or rather,
I think it's better to go down to a more simple use case, like a uniqueness of a specific thing, for example, of the code of a product, for example, the SKU or something like that. That does make more sense, because yes, you have a logic on the compute side, but you have a constraint on the database as well, which is fairly easy to implement. So you will get an error. So even you can say that the SQL, which is quite standard, so it shouldn't be an issue with agnosticism. Yeah. So it's basically SQL standard. You should be able to check for uniqueness, and you could try to write this or update this line and handle the response of the database.
You can't globally, right? So if you want to guarantee uniqueness, you need a transaction for that. And that is only guaranteed if your database is not clustered, which is the whole point of today's episode, right? It's like, that's why NoSQL databases exist.
Okay, that's a fair point. That's a fair
point. Because a NoSQL database can tell you, I guarantee that it is unique as long as you haven't just created this record. Right? If this record existed before, I can guarantee that you are now talking to the correct node, and it only exists on this one. So as long as you talk to this one, it is indeed unique. And by virtue of not having been created just now, I can also guarantee that it is unique globally. Because if it wasn't globally unique, then you would have connected to a different node, right? Because that's what the clustering capability allows you to do, which is a guarantee that the SQL server can never give you. I mean, nowadays with Vitess, you can query all the nodes and ask them for quorum, but that is then a performance consideration that you need to take into account. This is becoming a too complex example. I would much rather go through the comments right now, and then we can come back to this. Because eventually we'll talk about CQRS.
Let's stop waffling. Ty asked,
no more
but
waffles.
Eventually you will. I need a waffle later. But eventually you will be writing reports and doing analyses And that's going to be done in the materialized views or complex queries,
Yes.
which you will want to cache or export, like you said, Dennis.
Exactly.
Ciao.
But the point is that you can then do on an OLAP database that was synced from, or maybe that you can do in a NoSQL database that was synced from SQL, or maybe your primary compute is on a NoSQL database, and then you synchronize all of that data into Aurora, into a data lake, and decided to keep it structured or schemaless or with schema or partially with schema. And then you only have that problem in the OLAP side of the business, in the business intelligence side, but not on the transactional side. This is primarily how people use DynamoDB, right? So it's the e-commerce side is built to handle Black Friday, and then the OLAP side is handled so that Steve, who has no idea what he's doing, can run any query of any complexity for any amount of time period in the past, and he can pay as much as he wants for that database cluster's RAM needs. But we don't want we don't want that to negatively affect the cluster, the hot write cluster on production. Kaloyan, the appeal of NoSQL back in the days were the faster writes, as there are no structure index to updates, right? So that's also a consideration of.
Try to explain that in a kitchen example.
Kitchen example.
Because it's Kaloyan.
God damn it. Oh, that's hard. That's hard. Yeah, so I don't know what it was, if it's a Jewish tradition or if it's some kind of, but for my ayahuasca retreat, we were in some like weirdly organized multi-kitchen apartment complex, and all the plates and all the forks and all the knives were numbered. And they had to be stored in a very specific shelf. And that's kind of the kitchen example that I can highlight here, in that if I were to take a fork, I would then have to go check. And I think the idea was in that it was, I don't know, it was meant to be kosher, or it was meant to be sort of not touch or halal. I don't know which. I'm not too versed in that sphere, but I think the point was that there were sort of rules of usage, and when I cleaned it, I would have to put it back in the right cupboard or in the right shelf or in the right box. So the idea with indexes is that indexes enforce a sort of double write, triple write, quadruple write rules. And sometimes when you're doing bulk updates, the indexes are either guaranteeing atomic writes or bulk updates, but never both. They're not optimized to do both. And usually, in order to read from a large database, you will want indexes, because they don't do the SQL databases are not optimized to do hash lookups very well. NoSQL databases are, unless you index the primary column, which by default you do. That's why you have a primary column. So at least the hash lookup is fast. But what it's not very good at, is storing multiple correlated pieces of data close to each other, like a columnar database would, right? So the SQL databases keep rows together, whereas columnar databases keep columns close together, right? So it's very hard to say, give me all rows between Monday and Friday, if Monday and Friday are not the primary key. But it's trivial to do in a columnar database, because the columns are stored together. So I could just get exactly the 7 columns, and then I can hash fetch them and give you back the 7 rows that you requested that match those columns. So that's one of the aspects of it.
Okay, then next one. Dennis does sell bed covers with his photo in it. So I would recommend to take a look at his blog. He's selling that one.
We need merch for Dennis's infinite knowledge on database madness. Who was this? What's going on?
Thomas too.
Thomas Schake. Thank you, Thomas.
I see Adrian, I see Dennis. ACDC.
ACDC. Yeah, DC. If you take away the ch, it is my initials. Yeah, but AC Adrian. Yeah, if you make a C, then ACDC. That's great. I love that. Ty mentions, more often than not, I've seen a NoSQL database being used as a fantastic way to shoot yourself in the foot. Most of the projects that I've used, one would be much better with the power and constraints of SQL. Yeah, so most of the time that I see this happen is only on MongoDB. This exact phrase I see with people who misuse MongoDB, and particularly people who use
How do you
MongoDB.
misuse MongoDB?
Well, you treat it like an SQL database. You have documents, but the documents have a schema, and then at a certain point you start writing SQL queries in MongoDB syntax, right? So I think that's the primary use case, because MongoDB was not meant to be used that way. MongoDB was actually meant to be used so that you could put JavaScript into your SQL. It doesn't have SQL. It's queries in MongoDB language, right? But you could write those queries in JavaScript. So you could have very simple transformations.
You can have functions in the database, which is quite
not
interesting.
Functions, but more like declarative. Imagine, reducers, mappers, flat map.
Yeah, this is what
like
I mean. Yeah.
So you have an aggregation pipeline in MongoDB, and you can. The point is that those functions, that JavaScript, runs on the database, not on your computer.
So I would like to query your database brain, which seems to be very great. So you have some credibility. So when do you use we have in the title SMBs, so smaller companies, not larger companies. When is the use case for you met for a MongoDB, and when would you say just go with something structured? Where is the main difference? If you just can point out one big main difference and maybe a second one, what would those look like?
So MongoDB definitely, when you're looking for right clustering across a large geographical gap, or you need a high guarantee that you want redundancy on your write nodes. So close together, but you want several of them, and you want to write to all of them. And you know that is a strong business critical property that you want your database to have. Because you can do that with managed SQL servers as well nowadays on AWS and GCP. But it usually comes with a caveat of, yes, you can do this, but you're not allowed to use transactions anymore. And usually when I see developers being told that they can't use transactions in their SQL database, they sort of have a fit. And I would much rather than you actually use the tool that was meant to carry that kind of workload, which is MongoDB. So that's one aspect. If you have a lot of JavaScript, specifically JavaScript transformations, and if you're connecting that to some kind of GraphQL federator, absolutely MongoDB is a great solution for that. Especially if you want good sound partitioning.
So again, do you refer to the MERN stack in specific?
No. Well, what I'm referring to is that your backend is also in JavaScript, and you would want to do like a materialized view, but you want the aggregation code to be written in JavaScript, not some.
So you have basically you write an application with a typical focus of front end, and backend is just
UI
the Jamstack idea,
Jamstack idea, limited. I want as little backend code as possible. So I want to have a few materialized views that create a tree structure for me, because you can't do it in SQL, right? In SQL, it's always two-dimensional. So it's very difficult to have data sets prepared already in such a format that might be native to what GraphQL needs as for a provider. But you can create aggregates in MongoDB that are.
Would you combine? You said that. Would you combine GraphQL and MongoDB at the same time?
I think that's a complex use case, not by default.
Because they are very similar in what they actually do for the receiving part.
Yes. But if this is a front-end driven team, I would much prefer if the queries they wrote was GraphQL and not MongoDB query language.
Because you could switch then later, or?
No, just because MongoDB has like a freakish query language syntax. and it's very easy to make a mistake.
Yeah, GraphQL is actually a very good point to have a good bridge. between front
GraphQL
and
gives you
back.
very simple linting capability, very good type interoperability with TypeScript. MongoDB doesn't.
But
so
if you would
it's
have
just fine.
primarily front-end developers who work in a full-stack manner,
I would prefer GraphQL. Yeah.
yeah, but it could increase the complexity actually of the backend in that moment. But yeah, you're right. This is on
Yeah,
the
if you
long-
have a
on the-
large backend, then do what the backend developers prefer,
Yeah.
which is probably going to be a Postgres database with JSON columns. That would be my preferred approach in that case. If you don't need the clustering aspect of it, right? So
and just
another
go down
thing,
to the basement and ask the developer what they think.
so another use case for MongoDB that I've already mentioned is if you have documents that have TTLs. So if documents have to disappear or self-destruct, or if you have a sort of increasing and lowering entropy kind of use case of I will write, and then delete. So for example, scores on a match or likes on a streaming service. I mean, nowadays you would also be able to solve that with things like Firehose and Kinesis on AWS if you're into more that camp of utilization. But in a small, medium business, Redis or MongoDB might be a
Redis,
much
yeah, I
better
would
fit.
say Redis is easy to use in this
Yeah.
case. Yeah.
Redis has even now, you can have consumer groups set up for how you're reading from streams. So you can even have strong guarantees of was this read, was this acknowledged. So you can actually read from streams in Redis with having full control over your delivery guarantees of do you want it delivered at most once, at least once? Do you want guarantees of durability if you need that, right? So Redis is extremely, and at the bottom of this article that I have on screen, it's in
That I
LinkedIn
just
chat.
removed. Okay.
It's okay. It's okay. No, it's okay. So at the bottom of the article, I also wrote a Redis article some time ago, and Redis has a lot of capability. You can have PubSub, you have native streams, you have God damn it, you have native streams, you have hyperlog logs, Bloom filters. You can store JSON documents and even get just a key from a JSON document, and the graph capability, right? So you can have neighbors that people obsess about how to do an SQL, and it's just if you have friends of friends of friends of friends, and you need 30-degree connections on LinkedIn, that's really hard to do with an SQL database. I haven't used GraphQL, graph databases or vector databases much outside of ArangoDB. I'm not an expert on that, so I can't really talk on that much.
Okay, but now SQL. So when would you recommend SQL in this case?
So we have a comment from Ty that connects to this. I just want to honor it before we move on. It says choosing NoSQL because it was cool, not because it was the right choice. It seems to me that going for NoSQL is the only right choice if you need a cluster of read-write nodes. Yes. Time series DB. Yes. Or something niche. Yes. Absolutely. Right. So use a NoSQL database when you need the NoSQL capability of the NoSQL database, and you're not going to abuse it as a SQL database.
I like the last sentence. I like the last sentence.
But definitely
everyone
not
is
for
building
a shopping cart
carts.
or CRM, something that, yeah. If you're building a shopping cart, Postgres is enough.
On some point, we were asked by a fellowship client. We have right now a partner, or a journey fellow, let's call it like that, that we should talk about what we're actually building. And this is just a small intermission now, maybe a topic for the next weeks. And it's about, we are building a software, which is actually what we're doing for our living, that resolves all the legacy systems which we had in the past or built in the past. And what Ty just said reminds me of that. And we had now some discussions with potential clients who will use that software. And the idea is that we all build the very same things, right? We're building user management, we're building authentication, we are building shopping carts, we are building this and that. And I think the majority of the stuff should not be built anymore. So it is a little bit about 60, I would even say 70 to 80% is very same in all applications.
Shopify exists for a reason, and it's targeting SMBs, right? So you don't if Ty, you ask me, what database should I use to build a shopping cart? My answer would be none, because you should be using Shopify because it has solved the entire spectrum of the problem.
Yeah, but
For a small medium business.
We should have a session about that, because on the strategic level, there is a new dimension of problem for the future, which is the SaaS aspect and the multi-tenant aspect.
But that is also solved if you want a headless storefront, or if you just
no, it's not.
If you don't want the storefront and you just want the back office.
Not for small companies. Not for small companies. It is overwhelmingly when you start to scale this, and we should have one. Not waffling now about that, but waffling in entire session.
Yeah, we should.
This is actually our entire business right now.
Yeah, we both worked a lot in e-commerce and SaaS, so I think we should dedicate a separate session about that. Thomas asks, could you repeat the name, please, Dennis? I understand Vitess. Yes, so it's Vitess, VITESS. It's a more recent open source project. It's basically handling connection pooling federation across multiple MySQL clusters. So this is basically what is nowadays known as a NeoSQL, where you have this like new SQL family of SQL products, which are primarily aimed at hyperscaling it for cloud native. So you're not managing a single database server that is of fixed size, but it can scale itself up and down without you knowing about it. Similar to DynamoDB. Or at least you know about it, but the scaling ceiling is absurdly far away, right? So the sky is the limit. Like you can't possibly have a workload that it couldn't fit. So those would be Supabase, PlanetScale, NeoSQL, Neon, right? So those are the more sort of cloud native oriented SQL, MySQL or Postgres databases. PlanetScale is, Supabase is Postgres, I think. And they handle this whole driver issue. And they also have a JavaScript driver, which is really interesting, right? So you can connect to the SQL server from the user's browser directly. You don't have to go through a backend server. Mm-hmm. That's also one of the more modern NeoSQL sort of headless Jamstack kind of mindset shifts. It's very unusual for us backend developers, or more backend oriented sort of technologists. Calvin mentions we used to use MyISAM autocommits for transaction safe logs, as the MyISAM records were never rolled back. Yep. If you mix MyISAM and the InnoDB queries in a transaction and you roll back, the MyISAM records won't roll back. So that's a lesson to be learned. But in your case, you wanted that, so But then it's really important that it's documented into the code that is actually an important byproduct of that decision.
Kaloyan, we sign you up for every stream. I could say we talk about teddy bears and you will come. That's great, actually. Love that.
Awesome. It's great to have you, Kaloyan. Tim mentions, progress is relatively unknown. Your sales in flight example is a business rule and should be wherever business rules are. Check when adding the sales tax. Did I use that example? Oh, the one with the e-commerce, the OLTP and the OLAP one. So I wasn't primarily thinking about sales tax. I was primarily thinking about the difference in use cases. So one use case had locality on the customer. The other use case had locality on the month, right? So the analytics person, the accountant, is looking at the month with some rules, whereas the customer is looking at their purchases from I want my account, right? So the SQL database is stored in such a manner that it is not optimal for both use cases, right? So it is guaranteed not to be optimally stored for both use cases. That's one of the drawbacks with SQL databases. Whereas with a NoSQL database, you could have two databases where one is optimized for one use case and the other one is optimized for the other use case. Or in case of things like ClickHouse or MongoDB, you could use the same database where the line isn't as sharp, where you could be somewhere in the middle and leaning more towards the hot side. If that makes sense. If not, we can go into a little bit more detail about that in chat or next time. Kitchen example, Kaloyan. Do you arrange all the plates by type using the SQL schema, or just put them all in a cupboard? The no schema fast, right? I arrange all of my cutlery by frequency of use. So the things I use the most are very close by, which means that if I have 6 glasses and we mostly use 2 of them, there are 2 glasses in one part of the cupboard and then the 4 other glasses in another part of the cupboard.
This is a cache then.
This is how I organize I have a write through cache. So my cupboards are always organized in a way that represents how I use them the most.
In my office, I have around 20 cups and I only use one, which is every time the same one.
Yeah, same for me. So I have one place where I put that 1 cup, and then I have an archive of 19, which are far away.
So I can break 19 cups before I...
And my mother is the other way around, and it drives her crazy. Yeah. And every time she wants something, that one thing that she only uses twice per day, she has to like... and then move everything back. So...
So two comments to go. Let's go.
I think there's gonna be much more coming back. Oh, sales transactions, Tim said, not sales tax. Okay, I misconstrued that at the bottom. Sorry.
So Kalian asked, we have been using setups of NoSQL plus SQL, where the NoSQL is the write buffer as it is fast writes, and then with a cron job, the data is imported into the SQL following schema with all the requirements and relationships. After the reports and analytics can use this power of constraint of SQL. Yeah, it's a little bit like front-end anecdote. If you do offline first steps, you do it exact same thing. So you have something which handles quick responses, and then you start to dump it in the background into a store and synchronize that away to some persistent layer, right? So, and in this case, it sounds for me like the SQL is more the persistence, or does have the role of the persistence, while the SQL, the NoSQL version is then something. It could be a Redis, could be probably Redis. Sounds like Redis a little bit. It could be, let's say, if it probably it's not even persisted in this case. I could imagine that it is not.
Well, it might be persisted, but the question is, what are the durability guarantees, right? So how many hard drives, how many nodes would have to fail so that you would breach some durability guarantees? That's usually the biggest problem. You know, the SQL databases are solving this problem of, well, under the hood, it synchronizes to 7 hard drives, and you don't have to know about that. That's the problem it's solving. And NoSQL databases that are clustered are solving it slightly differently. They solve it in the way of, well, managing that NAS cluster is complicated, and it's a single point of failure anyway, because the cleaning lady can still trip and pull out the power plug. So what we want to do is we want to just architecturally solve it. We will have X nodes, and we can spin one up, spin one down, and whenever we write, we decide do we want guarantees on.
we had a cleaning person back then in the first company I was, and there was a small server room, and it was open one day, and this person was taking a how's it called again, a dust sucker. No, not dust sucker. It is the
and they unplugged the cable.
No, not plugging the cable. So how is it called again? The
vacuum.
The vacuum cleaner, right? And went back on the backside of the rack and started to play on the ventilation of the service of the pizza boxes. That actually causes several monitor warnings because the fans were monitored, and we got an incident, and no one knew what happens, and nothing was there, but it was very clean in that room, and that was actually no, we don't. So the company actually they still have service there. Well, and they are not storing anything.
So you can see that Kalian has a lot of experience with this, because also I used to work at a telco that had like very questionable staging servers, and we had the same thing, like tripping on the fire alarm and hitting the fire alarm, and then it shuts down the server room, or it locks the server room, and then it freaks out and pulls out cable. Like it's okay. So this was 15 years ago. Okay, nothing bad happened. But on Kaloyan's comment, when he mentioned a fast write and then with a cron job data is imported, these are different caching strategies, right? So this is a write through cache. I write to the cache, and then it will make itself to the SQL server at some point, right? So you start on the NoSQL side, and you go to the SQL side, right? So you have this very fast, slow layers, and you go very fast, slow. You also have a different strategy. You can, the traditional PHP servers use the opposite approach. We go to the slow server first, and then the first request is fast, and then after the first user, everybody's request is very fast, right? So it's this
The
browser
same with
cache,
IIS and ASP.NET.
browser cache, template cache, data cache, and then the SQL write, right? So you have different strategies here. There's also a hybrid approach where you can go to the compute and you can write to both at the same time. And then you can come back with whatever is faster. Obviously, it can cause split brain issues. And there's also the event sourcing side where you say, well, no, the SQL data, the NoSQL database is the durable store. You want to talk about CQRS and event sourcing. It's possible that you can just keep the data. So the requests, let's say the post requests, right? So the requests that cause mutation, you keep those durable in your NoSQL database, and you use event sourcing, and then you generate the SQL tables from the durable store. So you don't use your SQL tables, even though they're on disk, you don't use them as a durable store. You don't use them as the primary source of truth. And I think that's the main thing that trips people off of CQRS in event sourcing. But I've seen a lot of people not use event store DB or something equivalent. They use Postgres, both for the event store and for the projections. The projections in this case, which would be the tables, right? So imagine your tables are all materialized views from the event log. That's a great way of thinking about it, right? So it's the NoSQL side that's actually durable. Durable meaning that it has failure guarantees, that it is the thing that is guaranteed the fastest to be written to at least 2 hard drives in case you restart the server or you shut the server down. Or you can also do it, just SQLite and use that as a fast server and just write it to disk, and then you figure out how to manage the disk. Or if the disk is virtual, how to manage that.
Yeah, when Redis becomes expensive, now could be a good alternative.
Yeah, so that's also why I wanted to have this episode. And we have like 30 minutes left. Raoul has a Redis-related remark. One time use Redis both as cache and also as broker. It is an amazing broker. Quite simple and straightforward to use. It is an amazing broker. The event stream capability was only added recently, right? So it was the event streaming capability came in like 2018, 2019. So it's possible that if you're as old as us, if you're a millennial, you've never used Redis this way, right? The X read, the commands that start with X are the streaming commands, because you have basically Kafka in Redis. It's not as powerful, it's not as scalable, but it's very good. You have consumer groups, you have write guarantees, you have acknowledging receipts, you have write optimized, read optimized, at least once delivery, at most once delivery. You can do some crazy shit with Redis streams. And that's a NoSQL database, just to be clear. Redis is a NoSQL database. It is primarily operating in memory. It has a durability option where you can decide to use it on disk, right? So it writes the disk second. And it can also cluster. So, but that's the whole licensing issue. And I think we should talk about that now. Kalian mentions sign me up for the e-commerce stream. Tim mentions sales TX, meaning sales transaction. Yeah, okay, so that was a previous example. Raul, Adrian, you already made your decision already, yet you like seeing the options available either way. Do you know what that was referring to?
Raul, please explain.
Kalian mentions Instagram loves Redis. This is circa 2011. storing hundreds of millions of simple key value pairs in Redis. Yeah, Redis is amazing, especially for hyperlog and Bloom filters, right? So Bloom filters help you answer the question of, hey, does this exist? Does X exist? Did user see this page before? That's an amazing storage optimized way of Bloom filtering. The cups. He means the cups.
Ah.
Your cups in your office.
I was thinking I was talking about the next streaming topic, but yeah.
So what's worth mentioning is that there is this trend going on. It started with MongoDB. So there are these SSPL licenses going around the database management community, especially on the NoSQL side. On the SQL side, we've seen this as well, but I don't know. Our industry has more of an appetite for it. Oracle bought MySQL. MySQL is now an Oracle product. It is what it is. I'm personally a Postgres user. If Oracle bought it, I would probably start using something else. Because usually the most important features end up in the paid tier, and I'm already paying for the hosting of the server. I don't want to pay for the license of the server as well.
Yeah, that was one of my reasons going away from SQL Server or MS SQL, because it's actually one of the big bottlenecks. Take a look at Azure, how expensive they are.
And they are expensive because most of the licenses are based on the number of CPUs in the server or the number of nodes in the server. And if you're in a cloud setting, that can quickly get out of hand and have like unrealistic expectations on you. Or maybe it's just a second-hand deal through the cloud vendor, and then you're just getting ripped off on like double paying. Like it's a margin on margin on margin on the computes. I'm already paying for maintaining it, operating it, using it. Why do I also have to pay for the license of the database if it's open source? Right, so the SSPL licenses started with MongoDB. MongoDB was open source. And then at a certain point, they said, we're not making enough money out of this. So we're going to make it source available, but it's no longer open source. And then what happened is that MongoDB split, is that MongoDB primarily became MongoDB Atlas. And now most of the MongoDB learning tracks certifications assume that you'll be using MongoDB Atlas. And most of the MongoDB features that are very prominent or are focused on AI, vector databases, OLAP, analytics, monitoring as perhaps as a Elk Stack or Kibana replacement, are now all on Atlas. And Atlas is basically the flagship product, not MongoDB, not open source MongoDB. And that has caused a lot of other vendors to start creating alternatives. MLabs. Don't even know what MLabs is. Yes, so it must have disappeared if I don't know what it is. Kalia mentions Oracle bought Sun, and some before that bought MySQL. Yeah, so there were similar takes with Java as well, with the Android project back when the whole licensing issues were going on. But we will continue seeing this. This will continue. These kind of trends of large corporations buying, I'm just waiting for somebody to buy, I don't know, for Apple to chill out on WebKit or some other issue happening, and we will have another transformation. We already have DuckDuckGo being very popular as a browser alternative. So, but back to databases. So MongoDB was the first one. And then the second one that it happened to was Elasticsearch. So if you're old enough to remember Solar and Lucene from the Lucene project, it later became Elasticsearch, and then it was purchased. And then it went from open source to SSPL, right? So this server-side license that was source available, kind of, but you're not allowed to use it. You're meant to use it with a licensed vendor that you then pay for, and yada, yada, yada. Point being, the really cool features are not available in the free version. And what was the reason they did this? They did this because the company that ran the open source project, primarily Elasticsearch in this case, the license prevented them from basically demanding fees from Amazon, who have created a much better Elasticsearch alternative on AWS. So what happened is AWS, Amazon in this case, ended up making much more money from Elasticsearch than Elasticsearch. So Elasticsearch said, well, if you want to make money from Elasticsearch, from now on, you have to pay us.
Can you still run ElkStacks fine then?
Yes, because when that happened, Elasticsearch was abandoned, and a Linux Foundation supported alternative was created that is open source, that is called OpenSearch. Right? So the same thing that happened with Redis, the same thing that happened with...
It is ElkStack now, Owen?
I don't know whether that the acronym changed. I don't know, because it is, Elasticsearch is this kind of NoSQL database that has SQL capabilities, but it's primarily a text-oriented, any kind of text search is a vector problem. It's text vectorization. It is a vector database as well, but we don't talk about it that way. Again, this is not about Elasticsearch right now. The point is, a few months ago or a few weeks ago, Redis did the same move. And that was quite unexpected. So the Redis had this whole history of having, it is a seed-funded company that has a lot of money, that has an open source project, but then they also have these like huge licensing things, and then they were constantly poaching developers. Check out YouTube videos about Redis Corporation and the history behind it. It's quite messy. Point is, again, AWS, GCP, Azure, they were making much more money from Redis than the Redis Corporation. So they decided to go, dual license, SSPL, feature freeze on a certain version, and then from now on it's proprietary use. If you're running it as a vendor, you have to pay Redis a license fee if you're making more money than us, right? And then what happens? Community backfires. The Linux Foundation starts supporting all the developers who are being paid by Amazon to contribute to open source Redis. Went away from that corporate version of Redis, and they started investing into an open source alternative, which is now KeyDB and various. So expect that in the next year you'll probably stop using Redis. That doesn't mean that you'll stop using a NoSQL cache, but it just means that you'll probably start using a different Docker image that will be Redis driver compatible. And this is just, staying up to date with these trends and these news, I think is just part of the job. It's part of you staying up to date on what's going on in the ecosystem, why, and primarily what are the corporate pressures? Why is this happening? Because Amazon's Elasticache, if you remember it, prides itself of being a Redis and Memcache compatible drop-in replacement that you can just click a button and buy on AWS, right? Because the point of easy, frictionless substitution, right? As you mentioned, one of the qualities of interoperability and quality in a mature software organization is substitutability. And in order to substitute, you don't need to create a database that uses the same standard. You just need to be compatible with the driver, which is what Vitess did as well with MySQL. Because then you can say, well, it's compatible with the driver, but this weird one query has a slightly different third argument. That's okay, right? You've noticed this, right? SQL and Postgres and MySQL have different drivers. And by nature of that, their SQL languages have also diverged.
Yeah.
But the Redis projects, the MongoDB projects, all the alternative MongoDB replicas, they all have the same driver, right? So the language is the same. It's just that maybe some way of how they operate is different, right? So Redis, for example, has, I think, KeyDB. Redis is single-threaded. KeyDB is multi-threaded. The driver is the same. But it has some implications of what it means to be connecting to this kind of server that doesn't have to be understood by the person using Redis, but it might have a sort of more full stack DevOps implication, because you might be allowed to run a slow scan, whereas previously this was discouraged, even though the syntax is the same.
I just wanted to quickly mention something. The last topic, the one before with Redis, and being maybe not maybe seeing it vanishing over time. So even DigitalOcean as a cloud provider messaged us that they're looking ahead actively evaluating our options concerning the future of Redis at DigitalOcean, which means that they say up to I think Redis 7.2 everything is fine. And from that point on, they need to take a look. So there is a big uncertainty right now, which means that in one way or another, we are going to see a change here. I agree with you. If there is maybe there is a change, but the damage is already done, I think. You know, the wheels are already turning. The inertia is already there. That there is a movement to something different now. And as you said, Redis is very good, very fast, but it's already quite old. And new alternatives could be interesting as well.
And
to
what's
get
important,
even more performant. Yeah.
What's important is that Redis is an enormous project, but the code base is relatively small. So a few years ago, I think Redis only had like two maintainers, right? So the entire internet is running on Redis, and a few years ago, it only had like 2 or 3 paid maintainers officially dedicated only to Redis. All the other contributors worked at large FAANG companies, where it was their responsibility as staff engineers, as senior engineers, to contribute to the Redis project that those companies benefited from. And it's that thing that the licensing issue stops, right? It says, well, if you're a vendor, if you're a cloud provider, if you're, I don't know, a secondary hosting service or a SaaS provider, and you're using our technology, you need to pay us a certain license fee to be able to use this version of Redis. So Redis up to version 7.2.4, it's all backward compatible with the license. I think it was, what was it, a BSD license? I'm not sure. The old one, but it was an open source license. It was quite generous open source license. It remains under that license. And then from that point onward, Redis is source available, but you can't use it. You can't modify it if you're a vendor. There are some rules, right? So it's a dual license.
Yeah, it's actually not. It is impossible to that.
Which means that people have said, okay, January, Redis 7.2.4 made a fork. And then from then on, most communities are switching over to the fork, which is exactly what happened with MongoDB, which is exactly what happened with OpenSearch, Elasticsearch. I mean, this happens a lot on these kinds of technologies. We saw this happen with Redux. We saw this happen with Angular. We saw this happen with Flux, what later became TypeScript. This is normal, but it's very rare for this to happen on a stable, like old, boring technologies, which are considered stable software in the database sector, in the database industry. Because they are, databases, the SQL, Kalyan posted a very good link in the LinkedIn version of our event about the history of SQL. And it dates back to the 1970s, right? So SQL databases were a stable idea for the past 50 years. It's now that we're having this sort of new metamorphosis with we had a new interesting. I'm just reading what Kalyan posted. I need to check that out. Thank you, Kalyan. So it's just now that there's this metamorphosis where most of these cloud non-cloud native databases, SQL or NoSQL, are having a sort of transformation and going cloud native, right? So whatever they're if you remember the article that I shared on screen, whatever the issues were, which of those issues were not cloud native friendly? Well, the connection pooling is a huge issue. Data locality is a huge issue. Having like weird licenses is a weird issue. So all of those are being aggressively solved and iterated upon. And you can see this with things like, I think there are about 70 or 80 new SQL driver equivalent databases coming out every year. It's impossible that you stay up to date with them, right? So because you know the big ones. You know MariaDB, you know Postgres, you know Oracle MySQL, you know SQL Server, you know SQLite, maybe you know DB2, Aurora, which is an all-up optimized SQL database on the AWS stack. But there are a lot of new like NeoSQL solutions which just go balls to the walls on one quality. Maybe it's hyperscaling, maybe it's having a web API. Honestly, that web API thing, that was very surprising to me. That was, when I saw that, I was like, holy shit, this is really cool. Yeah, I think Supabase has that. I'm not sure about PlanetScale. The PlanetScale is MySQL. I misspoke earlier. It's Supabase, that's Postgres.
Supabase is okay. I actually Supabase is one of those things I read a lot about on LinkedIn, but I never really understood what it is. I don't know if I missed something, but it is mainly let's say advertised by people who advertise in Jamstacks as well.
Yeah. So what it is imagine it's if I gave your Google Drive SQL capabilities.
Huh? So it's basically NoSQL.
No, it is. No, the point is you're not paying for the server. Usually when you buy an SQL server, you say it has a hard drive. And it has this kind of hard drive or that kind of hard drive. And its limit is this.
So you basically structurally query S3 or what?
Yes. So there is no limit on the disk. That's the idea, right? So you don't provision a server, you provision many tables. And the server itself is not constrained to a box. Right?
Yeah,
okay.
Same as your Google. Okay.
So when you buy Dropbox or iCloud,
this is the reason why I never was interested in it, because it's for me totally uninteresting. Let's say I don't see a purpose in such things.
Yeah,
because
so it's like
this infinite scalability is it is the strange things is those technology are often made for
so it's like
very small companies.
It's like a PaaS database.
I understand, but yeah.
But it's like a database as a service, right? So you don't get the database server as a service. You get basically a database as if it were on a cloud-native shared host, where it will be on many disks, and there will be safe backups, and there will be some guarantees on how it operates and how it fails and what performance guarantees it has. But you're not constrained to the size. Same as with DynamoDB. You don't say, I need a 400 gigabyte server. What you say is, I need this many reads and this many writes, and I want this many to be guaranteed, and this is the maximum burst I want to survive. Same thing as with serverless.
So what I have missing key, or maybe we both, I don't know. It is not only a database, it's more than that. It's edge functions, authentication. It's basically a Jamstack.
Yes.
It is Vercel with database. You can say no. It's not Vercel.
No.
It's not.
Vercel is slightly different.
No, I will cut that out.
So one of the primary features it aims at is that it is aiming to be a safe database that doesn't have to be hidden from the front end, from the UI, through a backend server. Right. So usually how you'd operate is, I don't want SQL in my front end servers because that's not secure. So it has to go to the backend. So I verify what's going on, and the backend server is the only thing that has connections to my database. Okay. This is for Jamstacks, so that there doesn't need to be a database, a backend server anymore, and instead your front end server can open up a a web connection, a TCP connection, not to the backend server, but directly to the database, so that you let the user read from the database, but then you allow them to constrain what can they see. And usually it is their own data only, right? So the user you might have a server, and then you define which part of the server belongs to Adrian. And then Adrian can connect to the database, and Adrian sees all the tables, but only his own data. That's the idea. So it goes a little bit deeper. It has schema ramifications as well. So it understands some idea of what does user mean and what data belongs to what user. And then it allows you to sort of make queries like that.
Yeah, I understand it more. I just took a look at the landing page. I never took a look at it, to be honest. It looks interesting, but let's say still nothing I want to really use. It looks very opinionated, to be honest.
It's heavily opinionated because it is opinionated towards front-end engineers, right? So it's meant to be, that part is admin, this is public, this is for anonymous users. So anonymous users, when they connect to the database, they have access to like these tables or these rows, or they have access to these policies. They can't do updates, they can't do deletes, they can't do this. They can only read from like a select few tables. And then you bypass this problem, and it can handle many open connections, right? And then you bypass this issue of to convert your database to HTML. You don't need server-side rendering and then send it to be hydrated. You have the Next.js app or the PWA or the React app that has state management already built in, talk directly to the database without transformation. And then it transforms, it just manages its own state. That's the idea. Obviously, it also works as just a database. But I think it's a more expensive alternative for just that use case. Or at least it doesn't have the same security guarantees as
it is worth to understand it. So I need to revoke what I've just said last. So it is an interesting solution, maybe not for the use cases I know or I use right now. But it looks so, especially for the topic of paths, which is still a topic we need to do in a practical sense. It is a good comparison later on to compare a more traditional agnostic type of paths, like the DigitalOcean Air Platform, with Supabase, which is a more Jamstack serverless type of native cloud, a native cloud thing, right?
Yeah, serverless has the same issues, right? Serverless also suffers from traditional SQL databases connection limits, right? Because when the serverless function spins up and has a batch of events, it's meant to scale wide, which means that you need to be able to handle that many concurrent connections to the database as well.
One thing, we just have 4 minutes left, and I think we should wrap up. So at least I need to.
Let's wrap up. I want to read Ty's comment. So Raul, it's also, so we're talking about Supabase. It's also S3-like, so you can use it as a document store. You can just dump something onto a URL, right? So the whole point is it has a really rich web REST-like or signed URL-like authentication access, so that you can connect to it on a web protocol and dump data into it. And then later you can query it. And it has background task with WebAssembly support, so that you can actually run operations like background cron jobs, but on the edge, not in my browser and not on your freaking PHP server. Ty also mentions the killer features of Firebase/Supabase is real-time data sync and authentication and storage bucks. Basically, all you need to build a mobile app. Really exciting. Ty says that's what I'd use for building an MVP extremely fast. Yeah, I agree. I've done 8 base, I think, which is very similar to Supabase. 8 base is a low-code, no-code platform where you can build applications, UIs for applications very quickly. And the storage mechanism behind the scenes is Google Drive or something equivalent in the Google ecosystem. Firebase, Google Drive, a spreadsheet. You can also connect it up with Notion. So rather than having a database, you have Notion or Google Drive or Airtables, and then you connect that up to your UI, and then you can have that UI have seamless integration with logins in the Google ecosystem. So I can use my Gmail account with OpenID to log in, to authenticate myself to the application. And then I don't need to do user management. It's a really cool low-code platform, 8 base.
Okay, for everyone, So as you saw, Dennis is a quite proficient person, or he was titled as a brain in that area. So you can borrow his brain in this area. So I just want to advertise that a little bit. And you should, if you have problems in that area, or you want to, as a team, for example, this is what often teams need, how to actually get to the point where we can then solve technical modernizations, how can we solve technical problems, can we get to the next stage. And yesterday we talked about culture, so the very basics and the fundamentals. But this is already, let's say, you have a good culture, you want to go forward, but how, right? And there is where Dennis is just a great person to hire. So I just wanted to advertise this today, and just take a look at his blog. Great post there. Always when it comes to very deep technical topics, he is a great person to talk to, and you should do that. Okay, that's actually it for today.
I feel very humbled. Thank you. Should we announce the workshop we have planned for PAS today, or do you want to do that at some other time?
Let's do this next time then.
Okay.
We will have a PAS workshop, which is not on stream, but we will have that. But I will announce it next time.
Yeah, we're experimenting with let's say a higher level quality workshop, where it would be paid and would have live participants off stage possibly, so not live stream but like private, but in this format with a lot of hands-on coding and a lot of hands-on knowledge about how to set up in one of Adrian's most favorite cloud vendors, which shall not be named right now, but it has a blue logo.
Yeah, because of the PAS, actually. That's
because of the PAS. Shout out to Adrian. So as you saw, Adrian hit the right strategic questions today regarding databases. I really love the conversation about if I'm a business and I'm setting up an e-commerce shop, and if I'm setting up, why would I care about NoSQL? Why would I care about Mongo? Why would I care about SQL? Those are the right questions to ask. And if you find yourself stuck in a corner because your business has made clumsy decisions on that front or have deferred those decisions way too long, you might need a migration strategy. You can't just change your mind. You might actually need a way to figure out, okay, how do we do operations, keep the lights on, maintenance, and also undo some of our bad strategic decisions. Adrian excels at that at the CTO strategic level. His link is down below if you want to check it out. He also very diligently has been on a very, very successful streak of posts on Substack, and his quality is top-notch. Do give him a like, do give him a subscribe.
65 articles in 6 months. No,
and overall,
in 30 weeks. In 30 weeks.
Generally very likable person and very fun to talk to. I can talk to Adrian about everything.
I don't know.
Adrian about everything, engineering culture related, parenting related, German culture related. It's fun. It's always fun. We always find something waffle on about. Here's a quick waffle for those of you who don't get the joke. It's when we're waffling too much. But...
I'm hungry now. I'm hungry since 4 hours.
Thank you so much for being with us. Have a lovely weekend. Yeah, it's been a lot of fun. More topics on this, so definitely PAS coming next. E-commerce. We should do an episode on CQRS. And I still need to set up talking to Sander Hugendorn, with whom we should probably have an engineering culture talk. Great. Sooner rather than later. Thank you all so much. And
goodbye, everyone.
Goodbye. Sending you off with some lovely elevator music. And I will see you next time. Thank you for being with us, Tim.